Yeah, welcome back to the class once again. And as I told you, I paused and I will continue on this video. The other part, still we are on Avogadro's constant and the mole, the relationship. We are going to take some questions, sample questions. We are going to take some questions in this segment. Please, if this is your first time of joining me, please do work to subscribe to the channel, Fauzan Harun channel, and then touch the notification bell and give it a thumbs up if you enjoy it at the end of the lesson, and share it to so many of your friends to also benefit in the classes, to also benefit from the classes. Okay, so we are going to take some questions. How many atoms are there in 0.3 moles of sodium? How many, question 1, how many atoms are there in 0.3 mole of sodium? And we have given L as, of course, our value here, 10 to the exponent 23 per mole. 23 over mole per mole. So we are going to solve how many atoms are there. We are going to solve this question. If 1 mole sodium atom is equivalent to, per 1 mole is equivalent to 6.02 times 10 to the 23 atoms. 0.3 moles will be what? 0.3 moles will be what? Have 0.3 mole over divided by 1 mole times 6.02 times 10 to the exponent 23 atoms. So equals to what? You can use your calculator to verify. I have 1.806 times 10 to the exponent 23 sodium atoms of sodium. So this is the answer. If 1 mole contains per mole, so if 1 mole contains this, 0.3 will contain this. Simple. This question is simple. This question is simple. Alternatively, or meaning you can solve it, or alternatively, number of sodium atoms is equals to amount of substance times the Avogadro's constant. Amount given in the question is what? 0.3. So 0.3 moles times 6.02 times 10 to the exponent 23 per mole. You see? So mole atoms. So this per mole will cancel mole here. So we have 1.806 times 10 to the exponent 23 sodium atoms. So irrespective of the procedure you will use to solve it, you will arrive at the same answer. That is the scenario we have there. We are going to look at another question. So this is the first one. If you don't understand anything, I'm going to clean it. You reverse the video. Always I tell you to repeat the video. That is what we are doing here. So I hope I can clean it now so that we go to the next question. So we are going to look at the next question. And the next question says, calculate, I'm coming, let me kind of write it. Calculate the amount of oxygen gas. Calculate the amount of oxygen gas in 1.505 times 10 to the exponent 23 molecules of gas. And the Avogadro's already, L is equals to 6.02 times 10 to the power 23 mole. That's the Avogadro's we are using to calculate. And this also, the solution is straightforward. The solution is straightforward. Remember in the notes, I gave you the interrelationship between the number of molecules as well as the Avogadro's constant. So the relationship is if 6.02 times 10 to the exponent 23 molecules of oxygen gas contains 1 mole, then this one, the one I gave in the question, 1.5, then 1.505 times 10 to the exponent 23 molecules will contain what? So we have 1.505 times 10 to the exponent 23 all over 6.02 times 23 times 1 mole. And then 6.0, this one, 2 mole. You see, so if 6.02 contains 1 mole, this will contain these molecules will also contain what? Not per mole, molecules. We are talking about molecules here. So these molecules. So molecules here. So if 6.02 times this to the power 23 molecule contain 1 mole, 1.505 times 10 to the power 23 molecules will contain what? So is that divided by this one times 1 mole, which will give us, you can use your calculators, which will give us, I think, 0.25 mole. 0.25 mole of oxygen gas. Alternatively, you can also use the formula to do it. It will get the same way. Just like in the first question, you use the formula. You can do, I don't want to waste time there. You can do it. It's just change of subject. You make small n the subject. That's all. That's all. So we are going to take last example. We are going to take last example before we give assignment and end the class. we are going to give last example before we go and end this topic of Avogadro's constant, so that next time we will do molar mass. So we are going to take the third question, and I think the final example for the day. And the question goes, question 3, would you expect 0.1 mole of O2, that's oxygen gas, to contain the same number of atoms as 0.1 mole sodium? Explain your answer. Explain your answer. So solution. So this is the third question, the final question we are going to tackle before we go. Will you expect 0.1 mole of oxygen molecule, 1 mole of oxygen, I'm even trying to say the answer, sorry. Will you expect 0.1 mole of O2 or oxygen gas to contain the same number of atoms as 0.1 mole of sodium? Explain your answer. The first part is no. We don't expect it to contain the same number of atoms. We don't expect it, obviously we don't expect it to contain the same number of atoms. And then the reason is the reason is O2, reason being that O2 is a molecule, whilst Na is an atom. So if this is a molecule and this is an atom, certainly it wouldn't contain the same number of atoms, because one molecule of oxygen is equals to 2 atoms of oxygen. You see? Hence, if one molecule of oxygen is used twice 2 atoms of oxygen, certainly it wouldn't have the same number as one atom, and 1 atom sodium is equals to what? 1 atom of sodium. You see, so if the molecule has comprises 2 atoms, and the sodium comprises 1 atom, definitely the numbers is not going to be, number of atoms is not going to be the same. Certainly you can see that this one will have 2 times twice the number of atoms as this. So hence it can't be the same. So the first one, so I don't know if I can claim if you are okay, because I want to continue. In simple terms, let's calculate the number of atoms, because I said they can't be the same. No. So let me prove it. 1 atom sodium is equals to what? In the question you were given 0.1, 0.1. So 1 atom sodium is equals to 0.1 times 6.02 times 10 to the exponent 23 atoms. You see, so this is the value, the number of atoms of sodium. But in terms of the oxygen molecule, 0.1 here, so here is 0.1 mole atom of sodium contains this number of atoms. You see, so and so here to 0.1 mole oxygen molecules contains 0.1 times 6.02 times 10 to the exponent 23 molecules. This same molecule that you are seeing is equals to twice 2 times 0. So all this times 2, 0.1 times 6.02 times 10 to the exponent 23 atoms. So when you are converting them to atoms, because 2 atoms of oxygen is equals to 1 molecule of oxygen, in terms of number of atoms, you make this value twice. Hence, you don't expect them to have the same number of atoms. This will have 2 times as this. So that is the answer of the question. So you don't expect 0.1 mole oxygen molecule to have the same number of atoms as 0.1 mole sodium atom. Hence, they are not the same, because for every 1 atom of for every number of molecules or number of atoms of sodium, which is the 6.02, you get, in terms of the O2, which is a molecule, you get twice of that, 2 times of that when it is converted to atoms. So you get it, meaning because it is O2, 2 times the value of the number of particles of sodium is its value. Hence, no, you don't expect them to have the same number of particles. I don't know if you've understood me. If this is your first time joining the channel, please do subscribe to the channel and touch the notification bell. Share the program as well for viewers to enjoy and so many students to enjoy from the classes. Thank you very much for joining me on today's show. Hope to meet some other time. God richly bless you. Cheers and bye-bye.